The concept of this video is to present how I process big SQL data on a slow laptop without crashing it. The problem is I deal with big data, relatively big, millions of rows, and I have a small machine with only 16 gigabytes of RAM. So having so much data, you don't simply download 300 million rows, you don't collect the whole warehouse. You slice it by day, you create batches. So first you create constants like period start, period end, and create a sequence of dates through which later on the loop will circulate. So we will work in daily micro batches, not in one. We will not do one giant pool. Second, we will use parallel computing. We have the processor has something like 16 cores, and we would like to put all of them into work, not just one. So each worker opens its own SQL connection. On the other hand, the SQL server on the other side can say, no, I will not service you because you are doing some kind of denial of service attack, so I will limit myself to 4 workers. It's critical because we don't want to abuse our provider of data. So we specify how many workers we are going to use. We process one day at a time. So we will start here a function. And the real issue is the date type in SQL Server, which is different than in Apache Arrow and in R language. So we need to use a filter and specify the data type, or experiment a little bit so that we don't get errors. So on one side we specify the current day to be within a specific range, and we apply filter. On the other hand, we send commands, we inject SQL command so that the SQL server reads the date-time format. If event date is stored incorrectly or cast inconsistently in SQL server, you may get shifted hours, duplicate partitions, missing records at midnight, broken joins. Production systems rarely have one table. They look like this. They have fact events that are uploaded currently, some historical data, and then very old, very historical data, and we need to collect it all because later on we will do some analysis, build models. So this will look like usually like this. We will union them, and it will be lots of data. So we aggregate inside SQL if we can, so that our RAM memory is not burdened with the work. We do the sums, we do lookups, we do cleaning. As much as possible we send to the SQL server so that our laptop is not burdened with the work. And then after the data is processed, we need to download it on our laptop in the form, preferably in the form of a data lake. We don't put it into our RAM, random access memory, we put it on an Apache Arrow data lake. We partition it by year, month, and date, and you will see that on your computer there will be created a folder system with hierarchy, year, and then in the folder year you will find the months, and in each of the months folder you will find event dates. So we execute using the future walk. Future walk is a function that distributes the work among the many cores, the many workers that you have on your laptop. Thanks to that, we have incremental pipeline, parallel micro-batching, SQL side aggregation, Arrow data lake partitioning, and safe date filtering.